Okay, good afternoon. My name is Michael Karg, and together with Pierrick Koch, I'm going to talk to you today a bit about the MORSE simulator. And to give you a first introduction about MORSE, I would like to start with this little video clip that we did for a 1.0 release, which will feature some scenarios that are used, where MORSE is used all over the world. MORSE is basically based on the open source project Blender, which primarily is a 3D modeler, but it also comes with a 3D games engine that we use for our simulations. And a nice thing about this games engine is that it comes with the Bullet physics engine integrated. Bullet itself is also a state-of-the-art open source physics library. And as you can see in the videos, we got quite some different robots, different sensors, different actuators that you can use, and they are just shipped with the MORSE release. And we also got a human avatar, as you can see here, which can be used to perform human-robot interaction and really dynamically change the environment in real time. Basically, you can control this like in a modern 3D computer game, like, for example, GTA 4 or similar. So I hope this got you a bit excited about MORSE. The rest of the talk will be structured as follows. I will first give you a general overview about the MORSE project and give you little examples about its usage and the MORSE workflow on how to get to your simulation. Then Pierrick will take over and give you some more details on the technical side and also talk to you about human-robot interaction and distributed simulations. The MORSE project is a 100% open source project. It uses a permissive BSD-like license. And just 2 months ago, we had our 1.0 release, which included about 30,000 lines of code, mostly written in Python. MORSE has a very active community that evolved out of academics and is mostly also populated by academics. The project itself was initiated at last CNRS in Toulouse in 2009, and as for now, there are it contains contributions from over 12 institutions worldwide. For our last releases, we had 15 different individual contributors and over 630 commits in 2013 only. We also have more than 130 users on our mailing list, MORSE users. Plus, since MORSE is based on Blender and Bullet, you also have those open source communities which are also very active. So, but I guess you guys as ROS users, you probably all know or use Gazebo as your main simulator, or probably also had a look at Weebots. But there might be also some reasons for you to have a closer look at MORSE. For myself, for example, what attracted me to MORSE was the adjustable degree of realism. Since my research is more or less focused on high-level planning, I didn't want to spend too much time on lower-level perception stuff. So that's really nice of MORSE. It comes with some high-level sensors that you can just use if you don't want to spend time on object detection. You have a high-level sensor for that. You can even skip navigation if you want. MORSE does it for you. Also a great plus for me was the human avatar. Since I really want to change my environment dynamically in real time while the robot performs things, I can just, like in a 3D computer game, control a human, do pick-and-place actions, open, close doors, switch lights on. And other features of MORSE, it's completely hackable via Python. It uses open source projects only, so you can hack basically anything. Also, Blender for modeling is a plus. Especially since in the last year, Blender really evolved. And Bullet physics, I'll count that as a plus too. I know there's always some arguments between Bullet, ODE, but I'll leave this topic for now. MORSE also is middleware independent, so you can control different robots using different middlewares on different computers, since it supports multi-node simulation. So to give you a bit of an example of what you exactly would have to do to get your simulation environment running with MORSE, let us imagine you would like to do mapping of a kitchen environment with our Pier 2 robot, and I mean a 2D mapping in this case. I want to show you what you would have to do on the MORSE side. So first thing to do is we choose a nice name. In my case, I choose Pier 2 Kitchen, since it makes sense. And only type, open the console and run MORSE create peer-to kitchen. MORSE takes care of the rest. It gives, produces an environment where you can put your scripts, your robot, basically your definition of your simulation inside. It also creates a defaults.py file, which is basically the place where we define our simulation. As you already see from the ending, it's Python, so you can use basic Python to describe your simulations. In our example, it would look like that. First line, we import our builder API, that is provided by MORSE. On the second and third line, we add a peer-to robot and say we want to control it via ROS. Since it's basic Python, you could as well just enter a loop and add 10 peer-to robots. We did that, no problem. Afterwards, we add some sensors. In this case, for mapping, we add an odometry sensor, also controlled by ROS, added to the robot. I also add a keyboard sensor here, since while mapping, I want to control my robot via a keyboard. I should mention here I could also just add a motion controller and use peer-to teleop keyboard, but therefore convenience, I won't let Blender do the work for now. I also add the Hokuyo sensor, that's basically sent the laser scanner on the base of the peer-to. And on the last line, I'll load a custom 3D model of my environment. And that's basically everything. This is all the code you will need to get your peer-to mapping your environment with standard ROS tools. We now run our robot state publisher in ROS, we run gmapping and type MORSE run peer-to kitchen, and we can control our robot via the keyboard, drive around, and create a 2D map. Of course, the same environment, we could as well just run AMCL localization and localize our robot in MORSE. And if you want to go one step further and want to do navigation with our robot, the only things we would have to add were 3 lines of code in our builder script, which is a motion controller that MoveBase can use to control our robot, like on the real peer-to. Again, as I said, ROS is our interface added to the robot, and we have our robot, and we have our robot navigating in the environment. This is basically all we have to do to get your simulation running. It's really short, it's easy, and you can do it using Python. And now for the more technical part, I will hand over to Pierrick, who will continue from here.
Thank you, and hi everyone. So we'll start with the internals. So MORSE simulation is made of components. Base components are sensors, actuators, and robots. And all components in MORSE are extending those classes. They can be linked to interface, modifier, or overlays. And they are defined by mandatory Python descriptions, the same kind of script we saw before. And they might come with a 3D mesh. So here is a snapshot of our robots. Obviously, you can extend it and add your own if you want. Briefly, the one we will see the more often is ATRV for all the outdoor and field robotics simulation. And you have the peer-to, AirMax, the Yamara helicopter, and Jido, which is a last human-robot interaction, robot for human-robot interaction. Then the inner loop, so we have 2 interaction modalities, data stream and services. Well, if you come from ROS, you all know the principles. Data stream publish by MORSE for sensor and read for actuators. And we have a strong decoupling, so MORSE is not aware of middleware until we link a sensor or an actuator in general component to a specific middleware. So we can even have different middleware in the same simulation and for different robots. Modifier alters the sensor and actuator's data. So the same, there is no link, there is no communication, straight communication inside sensor to modifier is made outside by a dynamic link. And components, local data are external interface like socket or ROS. And yeah, services, as you know, can be synchronous or asynchronous. And principle, so for the interface, we have the basic socket and text that will work everywhere. And then we have different middleware supported. So ROS, obviously. And YARP, Genome and Apocalypse are last developed libraries. OpenRTM, we just learned a few months ago that few people in Japan just made a support for OpenRTM in MORSE. It's not yet merged in the source tree, but we might do it later. And MOOSE, which is a middleware developed at Oxford. So for the mapping, we use data stream oriented or RPC oriented, as I said before. And all the language binding are made in Python and can be easily extended through other language via Python binding. And so we can do what we call simulation introspection through socket interface. We have a simulation service running in parallel of the simulation that allow us to get data from each and every component in the simulation and control each and every component. And all the serialization and deserialization is made in each middleware classes. And basically for the socket which comes with a basic installation of MORSE is JSON. And you can find on the documentation a full list of supported components and related middleware objects and messages for us. Then we can see what you saw already is a human avatar. I will just add a few things that there is connection to control it through OpenAI and use Kinect to control the human avatar and interact with the robot through the simulation. So it has been done a few times already for different presentations. And we have all the code, everything is open source. Now I'm going to talk about multinode. So this is a basic video where we see two MORSE instances running in parallel. And in background, you have a multinode server. So here we select the left instance, and we move one robot. And on the right instance, we move another one. So at the moment, the only exchange data are the robot position. And in the future, we could add the join for arms. It's requested features that we will develop soon or later, I guess. And so for the moment, the idea is to be able to distribute the simulation of robots on different computers. For instance, all the sensors is taking quite a lot of CPU. For instance, all the LiDARs and cameras. And as soon as you try to simulate a multi-robot scenario, you happen quickly to get stuck in CPU, to get limited by your CPU. So what you can do in MORSE is just distribute the simulation of one robot on one machine, on one node, and another one. So that's what is working at the moment. We are doing a simulation of our ITRV on one machine and simulation of the Yamaha Air Max on another one. And in the future, what we want to do is a bit more complex, still the same, but more nodes. So we still miss synchronization, strong synchronization support, but it's going to come soon. So still missing, as I said, so I didn't say that. Faster than real-time simulation is not yet fully supported. An explicit timeline of event, so we don't have tags on what's happening in real time. Support for logging and replay, actually this can be easily done because Blender allows us to record everything, all the movement of each and every object in the scene since game engine was developed inside Blender for game and also for simulation interaction in between objects. So we can record what's called through F-curves, which allow us to then replay all the simulation later on. And everything is stored in .blend file. Full support for PR2. So for the moment, we support all the arms and sensors, but I guess what's missing is grippers. And so this is an interesting feature to develop. And of course, you name it. It's fully open source, it's BSD, so you take it, you do whatever you want. If you want, you contribute, and we will be happy to make your patch. And so, speaking about merging, there will be a workshop 6 and 7 of June in Europe, might be in Leuven, in Belgium. This is to be confirmed. We expect around 30 people. You're all welcome. It will start with a tutorial and then some discussion about design meetings, some meeting about discussion for design. And yeah, hacking party or bug hunting. And introduction with MORSE development. So you can already register on the website, morse.openrobot.org. And feel free to go there and edit the wiki page related to this event. And that's it for my part. Thank you. And
that one. Thank you. Questions for either of our speakers? Yes, right here.
I'm sorry, you're speaking about the depth sensor, or I did. Okay, what was the exact question again? Okay, the question is how much data we can generate in real time using our depth sensor. Actually,
maybe I can answer on this one. Yeah. So to be honest, we didn't benchmark completely all the data from Velodyne. We have two versions of Velodyne. We have one using raycasting, so this one is really CPU consuming. We have another one developed quite recently using the Z buffer from OpenGL. And this one can give us a lot of data. The thing is, we need to serialize them and send them through either socket or ROS. And actually, this is the worst part. At the moment, I would say we generated 640 by 480 Z buffer in real time on one robot in one simulation. So this is one shot, and then you need to turn your camera to have the Z buffer around. And we didn't benchmark this yet.
Bullet offers, it does offer the simulation of dynamics, which I didn't try myself. It should be quite good. And I guess you would like to see a now robot integrated. So I heard some colleague of mine will actually work towards that. So if you could drop me a mail like in 1 month, or I don't know his time schedule, but it is planned and it should be possible. Also with complex dynamics.
So the question is how to represent the interaction in multi-node in between two instances of simulation. At the moment, as I said just before, we just exchange the position of robot, and we specify, we make a link in between one robot and one specific node. And on all the other nodes, we just disable the physics simulation for this specific robot, and disable also all the sensor on this robot, sensor and actuators. And then the multi-node server will send the position of each and every robot on every node, and those nodes will update the position of the non-local robots. And so this allows us actually to have the interaction and to remove all the robots from the physics simulation. So the interaction in between two robots is just in between two nodes.
How hard is it to import a model from ROS? Does it support URDF codes?
Okay, the question is how hard it is to import models from, for example, ROS. Blender, it depends on how well your model can be imported into Blender. Blender does not explicitly support URDF, but it does support collada files. So, and there is, I know that in ROS there's a URDF to collada converter. I tried it like 2 years ago. I had some troubles with it, but you can basically convert your URDF file to collada and import those into Blender. But there's also heaps of importers and exporters for Blender for many other files. You can also, 3D Studio is no problem. Wavefront is one of the ones I saw. So there's heaps of files that are supported, but URDF itself not directly yet. But feel free to write and import it.
All right. Well, thank you very much.
Thank you.